All right, folks, our next presenter is Alan Wellborn. He is a senior environmental engineer with the Navajo Transitional Energy Company. Alan received a Bachelor of Science in Rangeland Ecology and Watershed Management and a minor in Reclamation and Restoration Ecology at the University of Wyoming. He's going to talk to us today about creating topographic diversity in reclamation and managed stormwater runoff. Please welcome Alan.
Thanks. As Mike said, my name is Alan Wellborn. I've been with Spring Creek for about since 2012. Spent all my time in Wyoming between Cole and Trona. And thought with last year's high precip, as Rich mentioned, I'd kind of go over what we've done at Spring Creek for managing that stormwater runoff and how we kind of did that through topographic diversity. So a little bit of background on myself to just kind of explain a little further. Mike covered a bunch of this, but kind of what I find unique is I was able to start as an intern and stay with the same company. So if you're perseverance enough, you can stick with what you like to do. A little bit about Intech. Intech was formed in 2013 to purchase the Navajo mine down in New Mexico. Hold a few other projects throughout the Powder River Basin, down in the Four Corners area as well. And in 2019, Intech acquired Spring Creek along with the other 3 Powder River Basin mines previously owned by Cloud Peak Energy. A little bit about Spring Creek in particular. We started mining in 1980. Mine production was before that, 1976, 1977. In 2023, we shipped 12.4 million tons of coal. We were the 8th largest coal mine in 2023. We have a single 80-foot coal seam, averages from anywhere from 400 feet down to 80 feet down. Operate with a 180-foot cast horizon. As you can see, our list of large equipment that we have there, we recently upgraded our large excavator, hydraulic excavator, to a more modern piece of equipment, a lot more efficient. And we have quite a few numerous safety and environmental awards. Most recently, we went 7 years with no lost time injury. Just kind of a list of the awards that we've gotten over the years, most recently there in 2018. A little bit of a layout to give you an idea of Spring Creek for those of you that are not familiar with it. We're situated just north of Sheridan, Wyoming, northwest of the Decker area. We've got about 1,600 acres of reclamation. We've got 5 pits. One of them, Pit 6, is currently being actively reclaimed. It was an open pit a year ago, and I'm now putting topsoil on it. Just kind of diving into the meat of the presentation, we'll talk about causes of stormwater damage. So you're going to have a high intensity rainfall on an unstable landscape. That's typically what causes your stormwater erosion, and that typically happens prior to your scarification. Often on steep slopes, right? Water flows downhill. The steeper your slope, the faster it flows. So typically, as your mines progress from lowest strip ratio to highest strip ratio, the further along in reclamation you get, the steeper your slopes get. Your longer drainages or your longer grades lead to a higher velocity of water flow, especially when there's no sinuosity. Typically our western topography of sloping hills leading into our post-mine topography is those steeper grades. When you're typically altering those typical boring slopes to incorporate more steep and broken features, that'll help slow down your water flow. What can we do to break up our terrain, break up that boring terrain, and not give water the opportunity to pick up momentum? We see this picture down here below of a long, flat, boring slope with lots of real erosion in it. What can we do to help eliminate that? Well, we can come in here and we can start putting in different topographical diversity, different substrates. We can alter our aspects of those slopes. If this will play. Oh, that's a picture. So here, we've got Our scrapers and our D6s, they're putting in some swales on what was once a long flat slope. Those scrapers are dumping in a large ribbon of topsoil, and that D6 is sloping it on either side. So typically you're gonna basically bring all this in and just watch what your water does and try to divert it around that area. So some more about your stormwater damage. Typically it's going to happen during your planning phase. So, you know, you're coming into springtime, you're thinking about your summer reclamation, boom, a June rainstorm hits. Now you've got some water damage. You're also doing it during your interim construction. That's typically when your soil's the most vulnerable because it doesn't have your stabilization features. It can also happen when your reclamation is complete. You can have, you know, large natural sheet flow events. It can be topographically aided just due to those large flows. So what natural effects are already in place to help mitigate this? You know, we've got rocks, natural rilling. When you look out on a hillside, there's exposed rocks, there's natural rilling that's already occurring that's starting to create that sinuosity. You've got water carved swales. So we try to simulate that in our reclamation. Kind of dives us into our successful reclamation techniques, starting with, you know, baseline topsoil sampling. We want to find out what type of topsoil we have. Then we're going to strip that topsoil, 2 lifts, A and B. We're going to backfill and grade, creating all that diversity. We're going to do our soil suitability sampling. So we want to find out what type of spoil we have. Can we direct seed into that soil, or do we need to put topsoil down? If we have to ameliorate that spoil, we're going to do those treatments. Then we're going to apply our topsoil, again in 2 lifts, A and B. And then we've got a whole bunch of different seeding techniques. We have 17 seed mixes for all of our substrates. Looking into our backfilling and grading procedures, you know, our overarching goal there is to help create diversity to help mitigate that direct water flow. So we're going to route our drainages through low areas, right? Our post-mine drainages typically are going to be where our roads are. Or you can think about it the other way, we put our roads, our haul roads, where our post-mine drainages are going to be. That way they're already in a naturally low area, we don't have to move as much overburden. We want to ensure that our slope angle doesn't exceed our revegetation capabilities, right? So we want to be able to safely put a tractor and a seeder on it for large acreages, or be able to walk on it to hand seed it with Rich's whirligig. We want to mimic our pre-mine features that are proven to handle precipitation. And we want to use our as-dumped mine surface. So that little figure on the right there, the black line, you know, that would be a typical overburden dump, your different lifts. That red line right next to it, that would be a rough grade. So we're keeping that same rough profile and just cutting down those steep runs to incorporate more sinuosity, less direct flow. We're going to add drainages where it makes sense using our cut and fill. Obviously, we don't want to move dirt clear across the mine site if we don't have to. We're going to convert our multiple level dumps into bench features. That helps break up those runs, create wetlands on hills, give that water a chance to slow down. We're going to use our pre-mine contours for additional features and stream channels when possible. We're going to rough grade to build our large features. And we're going to look at those moisture events, see what happens. You know, was there a failure that we didn't do? What can we learn from those precip events that we can go back and maybe alter our design on a future project? Say we have some in-progress reclamation that's already going on. We made an alteration to that plan, realized we had some excess spoil. What can we do with that excess spoil while we're regrading all that to create, you know, different alternatives for that water flow? Can we create additional swales? Maybe can we put in a whole nother drainage? You know, if we can add more avenues for that water to disperse and get away, that's going to help us. So when we're looking at our backfilling and grading plan, you're looking at your PMT versus what your as-dump surface is. So this map here with the greens, blues, and reds, everyone probably recognizes that as a cut-fill map. We've got, you know, our arrows there. We ran an AutoCAD profile on this and said, hey, we've got, you know, 15 feet of cut. right here on the south end, we need to push that to fill this low spot here to the west. So we'll create our cut fill maps on where to put our drainages, send this out to our operators. We give them a piece of paper. Our operators love to look at a piece of paper. They don't want to look at a computer file. So as we're working on this, we've given that cut fill map to our operators. They've come out here and done some work, and this topo was from a drone flight. These are 1 foot contours. So you can really kind of see how we took what would have been a long, boring slope and we added a ton of topographic diversity into this. Right in here, these topo lines widen out. We built up a little bench. We created, we've got 1, 2, 3, 4, 5, 6, and 7 drainages, low spots coming off this bench rather than just the 1 or 2 that would have channeled all that water off of there. Coming up here to be the southeast, we were able to bring in a little more material that helped our cut fill balance. We added a whole bunch of benches in. That gave us the opportunity to put some scoria there, some surface substrate, put in seed mixes that are more conductive to seeding into raw scoria. Another example of our PMT versus where we're at with our spoils. So the smaller lines, those are going to be our dumped in spoils, and then the thicker gray lines, that's our PMT. So that kind of shows you what we started with and what we ended up with. If you look at this blue line and kind of look against those darker gray lines and the thinner ones, you can see that blue line gives you kind of a natural drainage divide. We were able to take that natural drainage divide, go in with a D6, cut a little swale, and channel that water around there so it didn't go off a steep, long grade. We get into our drainage designs. We've got another goal there. The goal there is to provide an adequate drainage density for our slope area. We want to use our pre-mine contours as that basis. We want to use our pre-mine channel alignment and our sinuosity when allowed. Nature knows best, right? If you can mimic our pre-mine and our natural features, that's going to give us our best chance of mitigating that. We're going to use our slope and our drainage area to determine our channel width. We're going to hand survey that drainage during building, and we're going to check the profile during construction. That's when we send our surveyor out there and he's working with them. Every 10 feet he's taking a reading. He's going to call them on the radio and say, hey, you need to go 3 feet lower here, otherwise we're not going to have our drainage. We're going to use our smaller equipment. Our favorite tool is our D6 and our little cat excavator. If we need to, we're going to incorporate step dams, log weirs, dirt fingers that extend into the channel. And the goal here is to match our stream width to our pre-mine slope and our pre-mine drainage area. A whole lot of numbers in there. I'm sure everyone's familiar with bank full widths, belt widths, and your drainage acres, all that fun calculation. Second goal there is building our belt width, allowing our pilot channel to kind of develop naturally. If you start your pilot channel too deep starting out, it's just going to cut it even deeper. So we want to start with a small pilot channel and let it naturally develop itself. Another goal is it's got to be able to pass a 100-year, 6-hour storm event. So that goes back to this previous slide of starting with a smaller channel, letting it build itself out, and having the proper floodplain width. That's all part of our design consideration. Next goal there with our 100-year event gives us that design standard. So we want to create a template for our future designs. We can keep using that template further on down that drainage as we hit future reclamation fields. That allows the drainage to kind of self-heal itself, moving that sediment downstream as it goes. If you overestimate your flow, that ensures your drainage is going to be stable to carry most of those storms. Last year was a good test of that. It seemed like every other week we were having a large storm event. This model here just kind of shows you surveyed profile of a stream in design. So this is about halfway through. Sent our surveyor out. He said, hey, you still got 2 foot of cut at the top, but you've got 5 feet of cut at the bottom. So we'd send the crew back out. They'd work on it again. We'd resurvey it. Everything looks good. This next few slides here kind of shows you how we're developing that pilot channel, having the proper floodplain width so that it can develop itself. And again here, after a couple of years, couple storm events, that regraded channel worked itself in. This is a fall photo. Shortly after this, we were able to go in and clean up that topsoil, seed it. A little bit of kochia coming in here. This was a fall seeding a little bit further down that drainage. This field now has some of the most phenomenal sagebrush growth I've ever seen. I wasn't able to get a picture of it this spring, but you can walk out there and about every 12 inches there's a 2-inch tall sagebrush plant. This is looking up that same creek. This was in the spring of last year. We had planned to plant this, and they were calling for a snowstorm. So I figured, great, we can get it seeded. Got a little bit of residual moisture. We've got a week of sun, week of warm weather, dry this out. And that snowstorm came in 3 days early, dumped 6 inches of snow the first day, and then it never stopped snowing. So we ended up having to postpone seeding on this a little bit, but that's that same field with the sagebrush density. Also in this photo, you can kind of see some cross cuts about halfway down the field, down here towards the bottom, and then up at the surface. This is after we've seeded it. We cut these in with a John Deere tractor and just a subsoiler, and that gives that water a chance to slow down a little bit. So if we're looking at our special feature designs, that's another tool that you can use to help create some topographic diversity. Those special features can be scoria hills, they can be anything. You've got dozer tracking there. You can create scoria ledges. That's one of our favorite. So our goal there is to create features within our backfill to act almost as a traffic cone, right? You weave in and out of traffic cones. You don't just mow them over unless you like to for fun. So we've got long sloping hills that require physical features to divert that water around them. And we want to create both high and low areas to allow for settling of sediments. This picture here in field 7E, this field eventually received an OSM award for outstanding reclamation. This is a good shot. We've got a whole bunch of special features here. We've got rock piles, we've got cut banks, we've got lots of rolling hills in here. We've got a settling area down here. We've got a steep slope with a channel right in the middle of it. These features here in development, this is on a north-facing slope. This goes back to what Rich was just talking about, picking your seed mixes for your substrates and your topographies. So we've got a scoria check dam here. In front of that, we seeded a bunch of large bunch grasses, create almost like a water dam there. Below that, you're going to put your rhizomatous mat growing grasses to help slow down and absorb that slower water after it's come off of there. Down at the very bottom there, we put a whole rock feature along here, and that's going to create a water break. Just below that is the edge of the reclamation field where it drops to the haul road. If we put a large rock break on that ridge, that's going to help prevent channeling and gullying off that steep slope. Next goal is, we want to provide some large, rough substrate on the surface. What do we have a lot of in southeast Montana? Scoria. We've got a lot of scoria. So we're going to deep rip those areas and add some large run-of-the-mine scoria, 12-inch plus rocks, just on the surface. We're going to seed right into that scoria. Our sub-goal there, we want to slow down the water on the surface using a natural material. That also conserves topsoil as well. Close-up photo there of some surface scoria doing its job on a hillside. We save topsoil, seed right into that. Sagebrush and winter fat love this substrate. Next goal there is to maximize our resource and minimize our handling, right? Everyone loves to minimize handling because that saves you money, saves you time. So we want to reduce our spoil compaction by deep ripping our soil, 1.5 feet deep. Typically a D6 or a 16M blade with its rippers down is how we do that. We're going to generate a GPS file for our dozer, for our blade, and that's going to show them where to do all this amelioration, what's topsoil to put down. You can put text in there. CAT and MineStar is a great tool. We're going to apply about a foot deep layer of B horizon soil with dozers using grade staking or with scrapers as well. Then we're going to put our A topsoil on top of that. And if we can, like I mentioned earlier, we're going to conserve our topsoil and increase our diversity by using scoria or thinner layers of topsoil of B or A. If we can, we'll go in after we topsoil it and we're going to disc it up pretty rough. If we know this area has to sit over winter, we'll leave it rough so that way when the spring rains come, you're not just washing smooth, packed topsoil down the hill. This is just kind of a map of a topsoil laydown plan and all the different ameliorations that we've got to do dependent on our spoil quality and our seed mixes for our post-mine land use. Every one of those different colors hatches as a different substrate, different amelioration plan. That's our trusty disc, our sunflower disc. That's probably one of the best farming purchases we ever made. Parts are easy to get for it. It does a great job on our rocky scoria soils. We rarely break a disc, but we keep plenty on hand and they're easy to repair in the field. Our seeding techniques, our goal there is to match our species to our habitat and execute that consistently. That's really the goal there. After our soils had enough moisture, whether it's spring or summer, but not too much moisture, too much snow to make it muddy, we'll disc it, and then we'll disc it again if we need to. If there's still some large chunks in there, if it's got some frozen chunks, we'll disc it up again. Then we'll pack it, get that firm and consistent seed bed. We're lucky enough to have a guy who he plants wheat on his own property, does all his own farming, so he's really adept at farming, basically. We like to call ourselves the sagebrush farmers. Our seeding method has to ensure our proper seed and soil contact. You can't just throw sagebrush seed out there and hope that it stays there all winter through our heavy winds. We want to calibrate our seeders. We've got two different seeders. We have a sunflower seeder, and then we've got a grasslander. Your mixes can vary. All your rates can differ. They can vary from lot to lot, from provider to provider, so it's always good practice every year to recalibrate your mixes. And if you can, seed in the spring if possible, especially your grasses, to help reduce any crusting issues. That leads us to the next goal there of seeding at the appropriate time. You can seed in August, but if your soil dries out in August, you lose all your seed. So when's the best time to plant? Fall or spring. You basically have to become your own weatherman. Yes, everyone knows weathermen typically lie for their job on a daily basis, but you have to be able to forecast the weather. You learn all the good websites. NOAA, their websites are pretty good at weather predicting. Learning how to read radar. If the weather looks good for the day, great, I'm going to go seed 2 o'clock, there's no wind, but you don't look at the radar and see the giant ZF6 cloud that's coming in that's going to dump 2 inches of rain on you. Conversely, if you have a wet fall, trying to plant early in the spring to take advantage of your snowmelt to give those seeds a chance to germinate. Also there's planting in the fall, which I like to do for shrubs specifically. Kind of continuing on with that of matching your species to your habitat and executing that consistently. The right seed mix in the right place can control water. That's partly why we have 17 seed mixes, because we have so many substrates, so many different aspects on our mine. Continuing on with that goal, if you can use your quick growing bunch grasses that you need, using a competitive rhizomatous grasses in those longer stretches that would be more likely to reproduce from underground rhizomes as opposed to seed. That's going to give you a little bit better chance for establishment. Also including all those opportunistic shrubs, such as your winter fat and your greasewood. They can help anchor soil, especially if you have poor soil quality. That greasewood loves it. Don't know if that, okay, the red text is coming up there pretty good. This is kind of a good indicator of a good seeded area after a heavy rainfall. So on the left, you've got a drill row. So that's going to be your grasses. In the middle, there's a broadcast row. Then you've got another drill row, then a broadcast row, and a drill row. And this is that the packer, topsoil packer that I mentioned earlier. Again, easy to repair in the field. You don't want to have to track your equipment all the way back to the shop to fix it. And we've used the same tractor that we've always had. Key maintenance keeps it running, and it does a great job. This blue line here, you can see we're seeding across the hill, following the contours. That's another method also to help prevent water from channeling downhill. Another good photo of special feature use. This is a little on a lower area, but these rock piles with topsoil over the top of them gives you a good chance for wildlife habitat, gives you a chance to establish those shrubs and grasses on the bottom of these to create little wetlands. Here's our cedar that we use. It's our Old Faithful. So we've got your heavy grass seeds in the front, your light broadcast cedar in the back, and then press wheels and drag chains. And the key here, and this is a really good picture leading into our next photo, your seeds gotta touch the soil, right? You can't just have seed floating on the surface, you'll never grow anything. That's why we've got a heavy seed stubble drill, get that seed down to that first 1/4 inch of soil. Leads us to our next photo. This is after a fall seeding. You can clearly see our grass drill rows, and then scattered right in here in the broadcast, we've got some forbs and shrubs starting to come up right in between these drill rows. And just kind of wrapping up with some photos of topographic diversity and how it works. We've got some really good reclamation here on the left. This is our Par 6 area. This is some of our best grazing land fields that we have. This on the right is a transition between native and reclaimed. And this is let's see if this will go. No. This is a kind of a closer up that photo that I posted earlier of our scrapers coming down on some of our first large north-facing reclamation. Just seeded that this fall, so I'm anxious to see how all this comes out. Some more features on this slide, putting some scoria check dams in those drainages. In this photo on the right, you can see where that check dam slowed down that water, created a little sediment pool there. We'll go back in and hand seed over that if we need to. Again, substrate. This is showing that our shrubs really like this suitable spoil and scoria substrate. Everybody loves sagebrush. This is another one of our OSM award-winning fields, seeded in 1999, and this is a 2012 photo. With that, I'll wrap up. Any questions I can answer?
Thanks, Alan. Any questions for Alan?
Is a black lab required to be an environmental scientist?
Yes.
Yeah. I think we can let off easy there, Alan. All right. Thanks, Alan.